Well, sadly enough, we cannot reach Jeffry Tomkins in this little session with questions. So perhaps I can just say a question that we had and say some words about it anyway. It was about the interesting stick spiders from Hawaii, the Hawaiian Islands, and the fact that they have all the same genome but still look very different from each other. So the genotype is identical, almost identical, that is, but the phenotype is very different. And so the question arises then that in such case, some evolutionists say that that kind of mechanism, that is so-called epigenetic changes from the environment that doesn't affect the genome, that such changes can be dealt with within the evolutionary paradigm or theories. It's a part of what it used to be called the extended evolutionary synthesis. But it should be a problem for evolutionists. So the question was if that really isn't really a problem, because it ought to be. What do you think about that? Yeah, I think it really should be a problem if changes that really can affect the appearance of.
So you're thinking that changes, since they are changes that will change the interaction with the environment, and then still there's nothing that can be passed on, right?
Yeah, because if there is a natural selection on a special phenotypes, special appearances, then it has no effect on the genes. Somehow
because
the evolution in the respect of changing genomes is just off the line.
Exactly.
Somehow.
So I mean, one thing that some creationists used to argue is that kind of the resolution is not enough. Like natural selection can select only complete individuals, not individual genes. So this means that when it selects an individual, it will get a lot of, maybe one possibly positive mutation, but it will also get a lot of negative mutations. Yeah. So it's very coarse-grained. But this problem that you mentioned, it further aggravates the problem and makes it even harder.
Yes.
So natural selection really won't help much.
No, probably it's so. Yeah. We have this evening, there is, hopefully Dr. Jeffry Tomkins will be there tonight and perhaps can say something more about this. But and there are some other interesting things as well. Like it's not just that the human genome, that is the mitochondrial DNA, points to a time frame of some 6,000 years for mitochondrial Eve, but there is also recently research made that shows that of 100 out of 100,000 animal species, about 90% of them also have an origin about the same time as mitochondrial Eve. That is also something that hopefully Jeffry will like to answer, because it's a really an interesting find, really, that really strengthens the creationist case. So, but I think we have to leave Jeffry Tomkins there and instead go to the next speaker. Who's that?